Right, welcome back to part 2 of your test review. This is going to be starting with number 10. We'll see how far we get with this one. Might end up needing a part 3. Let's go. Number 10. This is a rational function. We've got some x's in the denominators. All right, so first thing we need to do is find our least common denominator. So first, we're going to find our least common denominator. And the way we do that is we make a list. Make a list of all of our denominators, x plus 5, and then 3x minus 1, and then on the right side of our equation we have a 1 for our denominator, so we don't necessarily need to write that because it would just be multiplied by 1. First we try to factor all these. We can't factor x plus 5, and we also can't factor 3x minus 1. Once we have all of our denominators factored, or once all of our denominators have been factored, we need to find unique denominators, or unique factors. So x plus 5 is unique. We don't have any others, so we use that one. And then 3x minus 1 is unique. 3x minus 1 is unique. So this is our least common denominator. Okay? So then, step 2. We now need to take that least common denominator and multiply it on both sides. So we have x plus 5 times 3x minus 1 times 3 over x plus 5 minus 11 over 3x minus 1 equals negative 1. Okay, so we're multiplying that entire thing by our least common denominator. Okay, so if we take a look at our denominators, we have x plus 5, which is going to cross off with x plus 5. So that's going to go away, leaving us with this guy times our numerator. So we end up with 3x minus 1 times 3. Minus, we then take this 3x minus 1. This 3x minus 1 matches with this 3x minus 1, so we are going to use this guy and 11 for our next term. So we have x plus 5 times 11. And then we're left with equals. Since we don't have any denominator here, we're just going to take this guy that's right there and multiply it by x plus 5 and 3x minus 1. All right, so now we're going to distribute to clean some stuff up. So we distribute here. 3 times 3x is 9x. 3 times negative 1 is negative 3. So then we have a subtraction sign. This subtraction sign is important. Make sure you keep track of it because we have to distribute here. So we have 11x plus 55. Equals, again, we're going to keep track of this negative 1. X times 3x gives us 3x squared. X times negative 1 is negative x. 5 times 3x is plus 15x. 5 times negative 1 is negative 5. Right, we're going to combine like terms, and this is going to end up being 3x squared plus 14x minus 5. So we need to distribute this negative into here. And we need to distribute this negative into here, which leaves us with 9x minus 3 minus 11x plus 55. That's a lie. There's a minus sign there. Minus 55 equals, we distribute that negative 3x squared minus 14x plus 5. Okay, we distribute a bunch of negatives. All right. So now we want to get, since we see this little square term right here, we want to get all of our terms on one side and have a 0 on the other side, on the other side by itself. So we're going to continue combining like terms first. So 9x minus 11x gives us negative 2x's. Negative 3 minus 55 more is negative 58 equals negative 3x squared minus 14x plus 5. Okay, so then from here, we're going to move all of these terms over to the left side. Okay, so we're going to add 3x squared, so we have 3x squared. We're going to add 14x's, so plus 12x's. And then we're going to add 5 to both sides, so we're going to subtract 5 from both sides, so minus 63 equals 0. Now if we take a look at this guy, we can see that 3x squared, 12x, and 63 all have a 3 in common. 3 times, we're left with x squared plus 4x minus 21 equals 0. So now we have a thing times a thing equals 0. One of those two things has to be equal to 0, so we know that 3 is never going to be 0. So all we have to do is say that x squared plus 4x minus 21 is equal to 0. Okay? So from here, we're still trying to figure out what values of x make our original statement true. All right, so from here, we then factor. Are there two numbers that multiply to be negative 21 that add to be 4? There are. It's 7 and negative 3. So x plus 7 times x minus 3 equals 0. Then x plus 7 equals 0. X minus 3 equals 0. X equals 7, negative 7. X equals positive 3. Okay? So now we need to check. Now we need to check our answers to see if either of these, if either or both of these don't work. Okay, so we're going to take and we are going to plug our x equals negative 7 and x equals 3 back into our original problem. Now, there's a sort of a shortcut that we can use when we are checking to see if either of these work. Essentially, if we just plug both of these into just the denominators, if they end up not making either of the denominators 0, we can safely assume that those are going to end up working and making the entire statement true. So if we take negative 7 plus 5, so this denominator here, we're going to end up with not 0, right? Negative 7 plus 5 is negative 2, so it's not 0. If we plug in negative 7, 3 times negative 7 is negative 21, minus 1 is still not 0. 3 times negative 7 minus 1 doesn't equal 0. 0 in the denominator is what's going to cause these things to not work. So we can say, all right, 7 is probably a good solution. And then if we take 3 and plug it in, we can say, all right, if we plug in 3 to both of these, well, 3 plus 5 is not going to be 0. And then 3 times 3 minus 1 is also not going to be 0. So both 7 and 3 work for this problem. Both 7 and 3 are valid solutions for this problem. Okay? That's how you would solve a rational problem. Oops. All right, here we have a square root. So this is also on that additional video that was attached to your test review. So this is on that additional video. Our first goal is we want to get the square root term by itself. Okay, here we have that minus 2. So we're going to add 2 to both sides. So we get 6 plus 2n equals 4. We're going to add 2 to both sides to get the square root by itself. Once the square root's by itself, we can go ahead and square both sides. So we can say, all right, this side squared is going to be the thing that is underneath the square root. So the squaring of a square root makes it go away. And then 4 times 4 is going to be 16. And now we solve for n. Subtract 6 from both sides. 2n equals 10. N equals 5. Okay? So that's all there is to that. And again, we want to check and make sure that n works. So we have, again, the only thing that's going to really make this not work is if we have a negative number underneath the square root. So square root of 6 plus 2 times 5. The only thing that's going to make this not work is a negative under here. Positive plus a positive is going to be a positive number. So 5 does indeed work for our process. Okay? So on to the next problem. Very similar to the last one, except this time we have 2 square roots. So it's going to be a little bit more work on our part, but it's not impossible. Okay. Our first goal doesn't change. We want to get the square root term by itself, which right here we have a square root term that is by itself. So we're going to take and square both sides. So we have square root of 4x minus 11. Oh, sorry. Plus 2. That whole thing is squared equals 6x minus 5. Okay? But in order to square this, remember what squaring something means. It means that you are multiplying something by itself. So square root of 4x minus 11 plus 2 times square root of 4x minus 11 plus 2. So we're multiplying these two parentheses together. Okay, so this term times this term, times this term, you're going to effectively square it, so the square root's just going to go away. So we have 4x minus 11. Then this term times this term, so then that is plus 2 times the square root of 4x minus 11. Then we have this term, this 2 and this 4x minus 11. So that's plus 2 square root 4x minus 11. And then 2 times 2 is going to give us 4. Combining like terms, negative 11, so we have 4x, and then negative 11 plus 4 is going to be negative 7, plus 4 times the square root of 4x minus 11, because we have 2 of them right here and 2 of them right here. Okay? Come on. Come on, little eraser. You can do it. Okay? So, that's this left side of the equal sign, and we have 6x minus 5 is the right side of the equal sign. So we need to rinse and repeat. We need to do step 1 again. We need to get this square root term, or excuse me, this square root part on one side of the equation by itself. So we're going to subtract 4x and we're going to add 7 to both sides. So we have 4 square root 4x minus 11 equals 6x minus 4x is 2x, and then negative 5 plus 7 is plus 2. Okay, so from here, we still want to get this term by itself, so we need to divide both sides by 4. We have square root 4x minus 11 equals 1 half, let's just do, 1 half x plus 1 half. If we divide both of those by 4, we get 1 halves for those. All right, so then from here, now we have this square root term by itself, so what we can do is we can square both sides of our equation. So then we say, all right, 4x minus 11, whoopsie daisies, 4x minus 11 equals 1 half x plus 1 half squared. All right, and again, we want to make sure to remember what this thing means. All right, this is going to be 1 half x plus 1 half times 1 half x plus 1 half, and we distribute. So this is 1/4 x squared plus 1/4 x plus 1/4 x plus 1/4. Combining like terms, when you have two, so we have 1/4 x squared plus 1/4 plus 1/4 is 2/4, or 1 half x plus 1/4, and that all is going to equal 4x minus 11. All right, so we can go back and use that same idea of the least common denominator. If we multiply the entire equation by that least common denominator, so multiply the entire equation by 4 in this case, we can get those denominators to go away. So we have 16x minus 44 equals x squared plus 2x plus 1. Right? And now we want, since we see this square right here, we want to get everything on one side and 0 on the other. So we're going to subtract 16x and add 44 to both sides. 0 equals x squared. 2x minus 16x is negative 14x. 1 plus 44 is 45. Okay? So now we want to ask ourselves, are there two numbers that multiply to be 45 that add to be negative 14? And it just so happens that there are. So 0 equals x minus 9 times x minus 5. Right? So then 0 equals x minus 9. 0 equals x minus 5. and then 9 equals x, and 5 equals x. So now we need to check, see if either of these are going to cause us to take a square root of a negative number. All right. So 4 times 9 is a large number, minus 11. That's going to be okay. 6 times 9 is going to be a large number, minus 5. That's going to still be positive. And then 4 times 5 minus 11 is still going to be positive. 6 times 5 minus 5 is going to be positive as well. So because we are never taking the square root of a negative number, this works as well as this. So on to the next problem. All right. So had you skip 13 and down, after these, you don't need to worry about absolute value equations. We just didn't quite get there. We'll cover it next quarter. So in this case, we want to solve this equation, solve this guy, and we want to solve it for w. What that means is we want to get w by itself. Okay. So if we start off with p equals 2w plus 2l, we want to get w by itself. Okay, so we're going to treat L and P just like they're numbers, and just like if we were moving them around like normal. So in order to move 2L to the other side to get W by itself, we need to subtract 2L. So P minus 2L. So minus 2L minus 2L. These go away. P minus 2L equals 2W. And then we want to get W by itself, so we want to divide both sides by 2. So P minus 2L divided by 2 equals W. Okay. Simple, straightforward as that. All right. Goal is to get W by itself. Goal is to get W by itself. So for the next problem, we have a rational system of equations, or rational equation. Ugh. Words are hard, kids. So we have fractions, so we want to find the least common denominator. So we make a list, A, B, and then the denominator on the other side is just 1, so it's just A and B. So our least common denominator is going to be A times B. So we take and multiply this entire fraction, or this entire equation, by A times B. When we do that, multiply that entire thing by A times B. A is going to go away here. This is going to reduce out, so we're left with B times 1. We have B times 1 plus, in this next fraction, B is going to reduce out with B, and we're left with A times 1. So B times 1 plus A times 1. And then that's going to equal 8 times A times B. Okay. So let's clear this up a little bit. We're going to get B plus A equals 8AB. Now our goal is to try and get B by itself. So let's get all the terms that have a B over on one side of the equation, and then let's get all the terms that don't have a B on the other side of the equation. So this guy has a B, and this guy has a B. So let's get them onto the same side, shall we? We're going to do that by subtracting B from this side and subtracting B from this side. When we do that, we get A equals 8AB minus B. Okay? Our goal is to get B by itself, and so the reason that we moved all the B terms over to one side is because now, what does this term have in common with this term? Well, they both have a B. So A equals 8A minus 1 times that B that we can factor out. We can factor out a B. Or maybe I should write it the way that we normally write this. Okay? So the term they have in common is B. We factor out that B, and we're left with 8A from the first term minus B divided by B is going to be 1. Okay? So from here, we then can take and divide both sides by 8A minus 1. So we have A divided by 8A minus 1, and that is going to be our B. That's how we get B by itself. Another way we can do this, you know what, let's just leave it at this. We'll call it good. All right? So, on to the next problem. So, we are going to try to solve this guy by completing the square. So we have x squared minus 3x equals 12. Now remember, we are hoping for a to be 1, which it is, good for us. And we also want to have it in the form we want to have it in the form just x squared plus bx equals some number c. And we actually have just that, some x squared plus some number times x equals some number. Okay, so the first thing we do for completing the square is finding the completing the square value, finding the value that completes the square. The way we do that is by we take the b value over 2 and square it, which in this case is going to be negative 3 over 2 squared. Now negative 3 doesn't divide nicely by 2. That's okay. That's not a huge deal. If it doesn't divide nicely, square the top, square the bottom. So we get 9 over 4 in this case. This is the completing the square value. So if we add this value to both sides, x squared minus 3x plus 9 over 4 equals 12 plus 9 over 4. We get our completing the square. We get our perfect square on the left side. Whenever we have a perfect square on the left side, we always have this as our solution. X, and then whatever this sign is, comes straight down and becomes our sign in our factored form. And then whatever value we squared here is going to go over here, is going to go in this spot. So we squared 3 over 2. Essentially, if this is negative, you should have a minus sign in the middle. But whatever the numbers are that you squared, go right here. And then that whole thing is just squared. Equals. Let's see, so 12 over 4 is equal to, so 12 over 1 is equal to 48 over 4, plus 9 over 4. We're looking at 57. 57 over 4. Yeah, that looks about right. So we have 57 over 4. 57 over 4. So then we are going to take the square root. X minus 3 over 2 equals square root of 57 over 4. This is going to be the same thing. Oops, plus or minus. Sorry, forgot my plus or minus. It's going to be the same thing as plus or minus the square root of 57 divided by square root 4, which is going to be plus or minus something over 2. So then the 57, if we make a factor tree, 2 does not divide nicely. Let's go with 3. 3 and it looks like, I think, 19. 3 and 19. 19 is a prime number, and 3 is a prime number, so it's just stuck as the square root of 57. There's nothing we can do with it. Plus or minus the square root of 57 over 2. So let's clean up a little bit. X minus 3 over 2 equals plus or minus square root 57 over 2. We have to get that 3 over 2 over to the other side. X equals 3 over 2 plus or minus square root 57 over 2. And that is our answer. We're actually going to conclude this particular review in part 3. So stay tuned. Bye, guys.